Firstly, I would like to thank the MAASI organization for giving me the chance and this opportunity to make this intervention, and also for the quality of work that contributes from a long time. In fact, my intervention will be around the use of a category of compounds from natural resources, the fruit of citrus, in order to preserve material from an aggressive phenomenon named the corrosion in such aggressive environments like the hydrochloric acid. When we talk about corrosion, we can describe it as deterioration leading the increase of the loss of materials and to the failure of equipment. And this phenomenon occurs in several fields, such as the transportation, the infrastructure, production, manufacture, and so on. If we don't find somehow to retard or to limit from these phenomenon, of course, we will have a lot of loss of budget. Our focus will be in the field of industry, production, manufacturing. When we talk about industry, we found that they use a lot the acids as a cleaning agent, and after finishing a production, they use the acid such as phosphoric acid, sulfuric acid, or the hydrochloric acid in order to clean the reactors and to clean the recipients from the impurities in order to launch other production. And the main problem of these acids, they have a lot of consequences on the material, and they cause a lot of corrosion. For this reason, we have to find some agents that we can interfere with the acid in order to limit from this phenomenon. For this reason, we focused in the use of the Polymethoxyflavones in order to mitigate these phenomena, the corrosion. And these kind of compounds were prepared from the citrus peels, and will mention a significant role in the next slides. When we talk about the use of natural resources as agent to preserve material, we have, in fact, we can solve a problem, but otherwise we will create another problem, because the environment is so important. So we can't cut the plant and destroy it in order to just keep the materials. But for our case, it is not this. We will not follow this process, because we will use only a waste which is already thrown into the garbage, the peels of citrus, and we will try to prepare some compounds that can be used in order to retard this phenomenon. Let's move to some technical tools that can be used to measure these efficiency. We started by the use of the weight loss measurement, which is an odd method, but it gives such a guide in order to know if we can use these material, if we can go more by using other electrochemical tests. By the use of different concentration from 25 until 100 ppm, we found interesting efficiencies, and as you can see from the figure here, as increasing the concentration from 25 to 100, we got until 90% of the efficiency. And after finding these results, we moved to the electrochemical impedance spectroscopy, and of course here we can see how much difference is between the use only of the hydrochloric acid, and when we combine it with 100 ppm of the polymethoxyflavones, we reached 500 centimeter square. And we can also see here the charge transfer resistance when we go from the use of the HCl only. We got only 20, we have 20.77, and when we use 100 we go until 492 centimeter square. From these results we conclude that this agent is an interesting mitigating that can be used in order to preserve the material. When we went to the skin and electrochemical microscopy, we found also interesting results with the use of the polymethoxyflavones. We have such uniform surface, and without the use of these kind of compounds we have destruction and there is no uniformity, as you can highlight here on the morphology of the surface. From all of these results we can say that these compounds they played pivot role in the prevention and the mitigation of corrosion failure, and these kind of compounds they can be act in both the cathodic and also the anodic reaction, so reduction and oxidation. They can stop or retard both of the reactions, and we got such interesting efficiency 95.78% with the use only of 100 ppm. We can go furthermore with the use of the PDP, the potential dynamic polarization tool, and also use other characterization method like the UDAX to get more information about the surface morphology.